All right, so let's look at an example where we want to fix or make it so static hazards can't happen. So the first thing we need to do is find our prime implicants like regular, like we're trying to simplify this as much as possible. So we got this big group of 4 here, and we've got an implicant of 2 here. Looks like we got an implicant of 2 here. And it looks like... so this is an example of a K-map that could be solved multiple ways, right? I could... this could have been solved a different way, right? I could have made an implicant going across the border here, and then an implicant here, and then an implicant there. Or I could do it the way I'm doing it, or potentially I could have an implicant going up across. There's lots of different ways that this specific K-map can be solved, but we're just going to do it that way. It is a right solution because if we look and find our distinguished one cells, there's one there, 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 there. So these are all essential prime implicants. So we covered all the ones using essential prime implicants, so we know that that is a good solution. Let's write the terms for these implicants here. So let's start with our big one first, actually. So what's staying constant in this big one? Well, we're going to say, here, we'll write that in black later. So we'll say A stays the same as a 1, and C stays the same as a 1. All right. Now what's staying constant in this term right here? Looks like B stays as a 1, and C and D are both zeros. So C prime, D prime. And what about this implicant here? Looks like A stays as a 0, B stays as a 1, and C stays as a 0. And finally, this guy here, A and B are both 0, so A prime, B prime, and D stays as a 1, so we don't prime it. Now we want to go through and find where our static hazards are at. Our static hazards occur anywhere where implicants share edges but do not overlap. So for example, this implicant shares this edge with this implicant, so we need to connect it with a new implicant. I realize that this is not an essential prime implicant, but it is a prime implicant, right? We couldn't make this implicant any bigger. So even though it's adding to our complexity, this implicant will help fix our static hazards. This implicant here, this blue one, also shares an edge with this implicant. So that means we can add another implicant there. And you got to be careful when you're searching for these edges, because it's really easy to forget about the fact that K-maps wrap over, and that this implicant shares an edge with this implicant. So we're going to put another group there. So in this case, all the implicants that we've drawn, they're implicants of 2. But remember, we want to always get as big as possible, right? If we can make them bigger, we need to make them bigger. In this case specifically, they're all pretty small. And then you might say, well, hey, what about this corner right here, right? These two edges are kind of shared, but that's false, right? They only share a corner. They do not share an edge. And besides, we can't make something that we can't make an implicant that covers those two, right? Because remember, these are if we're not showing the value, we're assuming it's 0, and there's no don't care conditions here. So that means that we're done, right? We've got all of our static hazards identified and fixed. So let's finish by just writing the terms for them. So let's do this one first. A and B are both 1. And it looks like D is a constant 0. Alright. And let's look at this guy. Looks like we've got A is a 0. C's is, A's a 0, so I need to prime it. C's 0. And D is a 1. So that's that implicant. And finally, we've got this guy here. And it looks like B is a constant 0. So B not, C, D. And there we go. So that is how we can fix static hazards from a K-map. If you're given a truth table, then you should go to the K-map and then use that same method on the K-map.